So in our final section of the text, section 10.7, we're going to be working with double angle and half angle formulas. And your vocabulary, again, is vocabulary you've already had before: sine, cosine, and tangent. I'm sure you all know what those are by now. So here are our double angle and half angle formulas. So they're different for double sine, double cosine, double tangent, half sine, half cosine, and half tangent. It's important to remember that the signs of these will depend on the quadrant where it lies, so you'll need that extra information because these can vary. Okay, so when we get into working with these guys, if I want to use my half angle formulas, I know that what I'm looking for in order to evaluate sine of 105, it feels weird that I'm calling this a half angle formula, but what I'm really going to work with is the sine of 210. Right? So the sine of 210 degrees divided by 2, that's 105 degrees. And why do we pick 210? Because 210 it's one of our standard angles. Right? So 210 is 30 more than 180, so it has a reference angle of 30 degrees, right? Or pi over 6, depending on whether we're working in radians. Typically, though, in these sections we've been working in radians. So pi over 6. Okay, so now this will be plus or minus 1 minus the cosine of A. Well, the cosine of 210 would be the x-coordinate, right? So the x-coordinate here would be negative root 3 over 2. So again, I'm going back to the unit circle. You could use what you've learned about reference angles. All over 2. Okay, so I know that the sine of 105 degrees, so the sine of 105 degrees will be equal to plus or minus the square root of 1 minus negative square root of 3 over 2. So first off, I need common denominators. So 2 is the common denominator. 1 is 2 over 2. Minus a negative is going to become plus root 3 over 2, all divided by 2. And so it'll be plus or minus the square root of 2 plus root 3 over 2 times 1/2, which is going to be 2 plus root 3 over 4. So this is the square root, plus or minus. So I know that my value has to end up to be positive, so it's not really plus or minus anymore. So this is the square root of 2 plus root 3 over 2, and it's going to be positive. So this would be my answer. Okay, so I didn't have enough room to put this work on the same page, so let me copy that and we'll paste it on here. Okay, so now we're going to do something similar here. We're really not going to work with 112.5. We're going to work with 225. So tangent of 225 degrees divided by 2. And you notice I have different formulas I could use, so let's decide which we want to do. Let's go back again to our unit circle conceptually. 225 is down here. It's pi plus pi over 4, right? Or 45 degrees if you prefer to think of it that way. Right? So this is going to be 4 pi over 4 plus 1 pi over 4. It's 5 pi over 4 is what the angle 225 is. And it's got a negative sine and a negative cosine, but they're both square root of 2 over 2. So I don't know which one of these is going to be easier. I'm just going to decide I'm going to use the bottom one here. I don't know why. I think I'd rather add than subtract. So I know I'm going to have negative root 2 over 2 over 1 plus negative root 2 over 2. Okay. So that means that my tangent of 112.5 degrees will be equal to negative root 2 over 2 times, I'm going to invert this, and I'm also going to create common denominators. So 1 is going to be 2 over 2. So the 2 here is going to be in the numerator, right, because I'm inverting. And over here I'll have 2 minus root 2. Okay, and when we multiply these together, these guys are going to cancel. So I'll get negative root 2 over 2 minus root 2. Well, I can't have this as a denominator. That's not okay. Though what I need to do at this point is I need to go ahead and rationalize my denominators. I, by the way, now realize it probably would have been easier to use the other formula, but I think I'm so far into it that I'm just going to go ahead and do this. Okay, I'm multiplying the denominator by the conjugate and also the numerator by the conjugate of the denominator because this is a fraction that equals 1. So I'll have 2 squared, which is 4, minus root 2 squared, which is 2. That takes care of my denominator. It's going to be 2. And here I'll have negative 2 root 2. I'm going to minus 2 root 2. And I'm going to have negative root 2 times root 2. That's negative 2. Okay, so if I factor a 2 out of this, I'll have 2 times negative 1 minus root 2. And I do that because those cancel, and it just simplifies to be negative 1 minus root 2. And that's simplified. Okay, so you go ahead and practice doing that. Do problems 7 and 8, and then come on back to the lecture. Okay, now we also have the ability to go ahead and evaluate some of these guys, right? So if I want to evaluate the exact value of cosine of 2a for this problem, right? I know that the cosine of 2a will be equal to 1, and I want to work with what was I given? I was given cosine, right? So I'm going to be, it's going to be 2 times cosine squared a minus 1. So that's going to be 2 times 4/5 squared minus 1. So this is going to be 16/25, but times 2, so I'll have 32/25 minus 1, which would be 25/25. So the cosine of 2a will be equal to 32 minus 25. That would be 7/25. Okay, if I go ahead and work with this particular problem, I know that the tangent of 2a will be equal to 2 times the tangent of a over 1 minus tangent squared a. So it'd be 2 times tangent of a, which is 2, over 1 minus 2 squared. So this is going to be 4 over negative 3. So the tangent of 2a, negative 4/3. Okay, pretty straightforward stuff. Go ahead and give that a try for yourself. Do problems 18 and 19. and then come back again. Okay, now we want to rewrite expressions without double angles. So mostly what this takes is comparing what I have, right? And the goal is without double angles or half angles. So where do I have a double angle? I have a double angle here. And what I did is I went back to this setup here and I found double angle. Which one of these double angles is going to work to simplify with that? So I went, oh, well, look, this is the same thing. So I went ahead and I copied that and I brought it over just to make it easy. But I can replace cosine of 2a with 1 minus 2 sine squared a, sine squared theta. So that over itself will be equal to 1. Okay, pretty easy. All of the problems are kind of like that. You just need to refer back to here to find out what's the best substitution to make for your double or your half angle in order for you to simplify your problem. So sometimes you don't have that many to choose from, but sometimes you have several, especially in cosine. So make the right choice. Go ahead and practice that with problems 13 and 14, and then come back. So if we want to solve a trigonometric equation, we have sine of x over 2. So this is a half angle, right? So if we go back and find half angle, sine of a over 2. So if I go ahead and work with this, I know that the sine of x over 2 would be equal to plus or minus the square root of 1 minus the cosine of x over 2, and that's all equal to 1. So if I square both sides of this equation, I'd have 1 minus the cosine of x over 2 is equal to 1. If I multiply both sides by 2, I have 1 minus the cosine of x. If I subtract 2 and add cosine of x, I have cosine of x is equal to negative 1. So where does the cosine of x equal negative 1? Well, cosine is related to x. That's going to be over here. That's where x is negative 1, so x is equal to pi. Okay, again, pretty straightforward stuff. Substitution and simplification. Try those problems 22 and 23. Hop on back, we'll finish out the lesson. Okay, so now we want to look at verifying a trigonometric identity. So let's think about the different trig identities that we have. I have a cosine squared, 2 times cosine squared, 2 times cosine squared minus 1, if you look at this guy here. So again, I'm comparing to my identities. We'll look at that. So 2 cosine squared a minus 1 is equal to cosine of 2a. So if I substitute, again, I'm going to substitute this for this. Then I have 2 cosine squared theta is equal to 1 plus 2 cosine squared theta minus 1. And the 1 minus 1 will cancel. I'll just get 2 cosine squared theta equals 2 cosine squared theta. And I have verified my identity. Go ahead and do a couple of practice problems like this. Do problems 31 and 32. And that wraps up all the lessons from this textbook.